Okay, in this lecture I want to solve two problems. The first one, exercise number 1. Let me write the problem first. Show that the sequence xn, n from 0 to infinity, defined by xn plus 1 equal to half xn plus a over xn for a greater than 0 and n equal to 0, 1, 2 and so on. Okay, converges to square root of a and find the rate of convergence. In fact, I want first to show that this sequence converges to square root of a, and in the second part I want to find the order of convergence. In fact, I want to say is it, for example, linearly convergence or in fact the second order of convergence. It's in fact quadratic. For the solve of the problem, let xn plus 1 when n goes to infinity be equal to x. So we get limit n to infinity xn plus 1 equal to half limit n goes to infinity xn plus a over xn. Now, look at here. We assumed that this is x. So, if we consider limit of xn, n goes to infinity, this one will be x and also this one will be x when n goes to infinity. So, we get x equal to half x plus a over x, and this is equal to half x squared plus a over x. Okay, now if we multiply both sides by 2x, we get 2x squared equal to in fact x squared plus a, and this gives x squared equal to a, and this gives x equal to square root of a. So the convergence have proved and we have nothing more to prove. Now we have to find the order of the convergence. To this end, let me define g of x equal to half over half times x plus a over x. So we can write xn plus 1 equal to g of xn, and it is equal to xn times xn plus a over xn. Okay, note, if we compute g of square root of a, it will be 1 over 2 times square root of a over square root of a, and this is half square root of a plus square root of a, and this is square root of a. This means that square root of a is fixed point of g of x. Okay, now we write the Taylor expansion of g of x at x equal to square root of a. So we get g of x equal to g of square root of a plus x minus square root of a times g prime of square root of a plus x minus square root squared over 2 times g double prime square root of a. Just 3, in fact, the terms is enough. Now, we compute g prime of x. G prime of x is 1 over 2, 1 minus a over x squared. Why? Because we have defined g of x something like this. So g prime of x is half times 1 plus 1 minus a over x squared. Exactly something like this. And this gives g prime of square root of a will be 1 half over 1 over 2 times 1 minus a over a, and it will be 0. So this term will be 0. Okay? Now we compute g double prime x. It will be 1 over 2, and here we will get 2 over x to power of 3, and this gives g double prime of x will be 1 over x3, and this gives g double prime of square root of a is 1 over a square root of a. Okay, in fact we should have a here, and also we get a here and a here, and finally it will be 1 over square root of a. Okay, now in the Taylor expansion here we consider g of x equal to, we get this one equal to square root of a, and this one will be 1 over square root of a. So we get g of x equal to square root of a. This term is 0, and this term is plus x minus square root of a squared over 2 square root of a. Okay, now compute g of xn. So we get g of xn equal to square root of a plus xn minus square root of a squared over 2 square root of a. Consider this one as xn plus 1, okay, and bring square root of a to the right hand side. We get xn plus 1 minus square root of a equal to xn minus square root of a squared over 2 times 1 over square root of a. In the problem, we assumed that this is en plus 1 and also this is en. Okay, so we get en plus 1 equal to en squared over 2 times 1 over square root of a. Taking absolute value, en plus 1. This is less or equal absolute value of en squared times 1 over 2 square root of a. And divide both sides by en squared. We get en plus 1 over square root of en squared less or equal 1 over 2 square root of a. So this is exactly the definition of the rate of convergence if we consider the limit form, and we get this alpha and we get this lambda. So we can say that the rate of convergence is 2 and the asymptotic value is lambda. And this complete the proof of the problem, and the problem now is finished. Now let me solve you another problem. The other one, example 2. Let me write first the problem. Let equation x squared plus ax plus b equal to 0 with b not equal 0 has two real roots, alpha and beta, if absolute value of beta is less than absolute value of alpha. Show that the sequence xn plus 1 equal to minus axn plus b over xn for n equal to 0, 1, and so on converges to alpha. Okay. Now, let me solve the problem. First, we define g of x equal to minus a xn plus b over xn. We have to show that this choice for g of x is okay, it's good. Okay, to this end, let me start from the equation. Consider f of x equal to x squared plus ax plus b equal to 0. This gives x squared equal to minus ax plus b, and this gives x is equal to minus ax plus b over x. Now, we say that put g of x equal to minus ax plus b over x. In this case, we get exactly this one. If I call this the right hand side g of x, we can get g of x equal to minus ax plus b over x. Okay, and this will be minus a plus b over x. Now, we claim, what we claim? We claim xn plus 1 equal to g of xn converges to alpha, which is fixed point of g of x. Okay? Now, to this end, we have to prove that the absolute value of g prime of xn is less than 1. Okay? So, we consider g prime of x and we compute it. If you compute g prime of x, it will be minus b over x squared. Okay? So, let me fix this. There is a mistake here. It should be minus. So, g prime of x is b over x squared. Okay? If we take absolute value from both sides, we get g prime of x is equal to b over x squared. But we know that in a second order equation, the coefficient of x is alpha plus beta, and the constant value is alpha times beta. Okay? So here we can get, let me put absolute value here, we can get here alpha beta over x squared. Okay? Now, compute absolute value of g prime alpha. It will be alpha beta over alpha squared, and it will be beta over alpha. And by the assumption, we will have absolute value of beta less than absolute value of alpha. So this quantity is less than 1, and it complete the proof that the existence of the fixed point, and in fact we show that the fixed point is, there exists fixed point for this sequence. Now, it remains to prove that the sequence xn, now let me write something. Now we should prove that xn plus 1 equal to g of xn equal to minus axn plus b over xn converges to alpha. Okay? Now, we say that choose k such that absolute value of g prime of x be less than k and k be less than 1. Okay? So, there exists an neighborhood we call it I of alpha, such that for all x in the neighborhood I, we will have g prime of x less than k and less than 1. Okay? We will get something like this. Now, choose x0 in the neighborhood. We have absolute value of x1 minus alpha is equal to absolute value g of x0 minus g of alpha, and this will be x0 minus alpha times g prime of xi1. Okay, and we proved that this value should be less than k. Okay, so this will be less than k times x0 minus alpha, and this says that this less than x0 minus alpha, and this means that x1 is belong to the interval I. In the same way, if we consider xn minus alpha, it will be absolute value g x n minus 1 minus g alpha, and this will be absolute value of xn minus 1 minus alpha times absolute value of g prime xi n, but we know that this is also less than k. Okay, so it will be less than k times xn minus 1 minus alpha. We repeat this cycle and we get k times g of xn minus 2 minus g alpha. This will be equal k times xn minus 2 minus alpha times g prime of xi n minus 1. Okay, n minus 1, and this will be less than strictly less k squared xn minus 2 minus alpha, and we continue in same way until finally we get less or equal kn times x0 minus alpha. So we get so far xn minus alpha less or equal kn times x0 minus alpha. Okay, take limit. If we take limit both sides, we get limit n goes to infinity xn minus alpha less than limit k squared times x0 minus alpha n goes to infinity. This will be x0 minus alpha as a constant goes out of the limit, and here we get limit kn, n goes to infinity. But here k is less than 1, so limit k less than 1 to power of n goes to 0, and the right hand side will be 0. Okay, so we get limit xn minus alpha will be equal to 0 when n goes to infinity, and this gives xn go to 0 as n goes to infinity, and this complete the proof of the problem. These two problem is our samples of in fact analytical problems that may be you encounter in the for example examination or in some books, and they are not too hard to solve, but you have to focus on the material that question want you prove. I will prove more example in the next lectures after the Newton method, and I will show you how you encounter with this kind of the problems. Please subscribe my channel, and please inform my channel to your friends. Thank you.